The Life of Walther Nernst by Nalia Johnson and Ellie Strawn. Walther Nernst was born in Bryson, West Prussia on June 25, 1864. He was the third child of Gustav Ernst, a district judge, and Ottilie Neger Nernst. He married Emma Lohmeyer, and together they had 2 sons and 3 daughters. Nernst went to the universities of Zurich in Switzerland, the University of Graz in Austria, and the University of Berlin in Germany. He graduated in 1887 from the University of Würzburg with his doctorate degree and a thesis on electromotive forces produced by magnetism in heated metal plates. After graduating, he became the assistant of Wilhelm Ostwald, who, with the help of Nernst, was establishing a new foundation of the theoretical and experimental field of chemistry. He accepted to be the physical chemistry chair in the University of Göttingen. Also in Göttingen, he founded and became the director of the Institute for Physical Chemistry and Electrochemistry. In 1905, in the University of Berlin, he became the professor of chemistry, and then later of physics. From 1924 through 1933, he was the director of the institute. He retired in 1933, and 8 years later, in 1941, he died in his home in Berlin.
Walther Nernst is most known for his work on thermodynamics. He is credited with the third law of thermodynamics, which is a law for electrochemical cells and the heat theorem, in 1906. The third law of thermodynamics states that as the temperature approaches absolute zero, the entropy of a system approaches a constant, minimal value. It also says that the entropy of a perfect crystalline state is zero at 0 Kelvin. It explains that it is impossible for any system to reach absolute zero in any finite number of steps, which therefore makes it impossible to ever attain a temperature of exactly 0 Kelvin. The third law of thermodynamics allowed conditions of equilibrium in many chemical reactions to be precisely worked out. It was also applied to industrial problems, including calculations in ammonia synthesis. Walther Nernst won the Nobel Prize in Chemistry in 1920 for his work on thermodynamics. Nernst also won the Benjamin Franklin Medal in 1928. Nernst is also known for his theory of galvanic cells. In 1889, he wrote this theory by assuming an electrolytic pressure of dissolution. This forces ions from electrodes into solution, which oppose the osmotic pressure of the dissolved ions. These equations, which describe the concentration dependence of the potential difference of galvanic cells, such as batteries, were of both great theoretical and practical importance. Also in 1889, Nernst derived equations which define the conditions by which solids precipitate from saturated solutions. In Berlin, Nernst focused on determinations of specific heats of solids at very low temperatures and vapor densities at high temperatures from the point of view of the quantum theory. In 1918, Nernst developed the atom chain reaction theory, which assumed that once the energy of a quantum has initiated a reaction in which free atoms are formed, these formed atoms can decompose other molecules with the liberation of more free atoms. Therefore, the reaction can continue for long periods of time unless affected by outside forces. Walther Nernst often found ways to apply the results of his scientific research to industry. The Nernst lamp, for example, was an improved electric light that used a ceramic body. After tungsten filaments were developed, the Nernst lamp was largely abandoned. Nernst also came up with an electrical piano utilizing radio amplifiers instead of a sounding board. Here, Nernst is pictured next to one of his pianos. Towards the end of his life, Nernst mostly focused on astrophysical theories, where the heat theorem had many important applications. There is now an award called the Nernst-Haver-Bodenstein Prize, which is awarded by the German Bunsen Society for Physical Chemistry in honor of Max Bodenstein, Fritz Haber, and Walther Nernst.